So for this question, predict the product and propose a mechanism for its formation, right? You have a ketone and you have an acid and you have a halogen, and there's a big question mark to find the product. And this will be your byproduct, which is also an acid. HBr is also an acid. So you have these options, right? You have option A to D, giving you few seconds to figure out what you think the product is going to be. Okay, now that you've had some time to think about it, let's look at the mechanism, and then we'll come back and then we will choose which will be the appropriate product. Okay, let's do it. It didn't want to stick. Anyway, so over here we have the mechanism, right? We are going to go through it, so don't be in a haste. Okay, I'm going to take you through it step by step. All right, so the mechanism for this reaction is in two parts. Okay, the first part is going to be Enol formation, and the second part is going to be halogenation. Okay, so I'm going to go through it with you guys. Before you create the Enol, or before you form the Enol from the ketone, the first step you have to do is protonation. So protonation means you're just going to add hydrogen to a system or to a compound. Okay, so over here you see the ketone. The ketone has some electrons on the oxygen, right? What we will do in the protonation step is to abstract a proton from the acid, right? The oxygen abstracts a proton from the acid. The bond between the hydrogen and the oxygen get thrown into the oxygen. Why? Because the oxygen has a plus sign on it. Anytime you see a plus sign, it simply means that the oxygen has an empty space or empty orbital for electrons to sit in there. Okay, so once you do that, this is what you get. The oxygen on the ketone now has a hydrogen attached to the oxygen. Oxygen normally would want to form two bonds. That's why you have a plus sign on this oxygen, because this oxygen has 3 bonds. So it undergoes something we call ketone tautomerization. It's just like resonance, right? So you have this plus sign. What is going to happen is that you can have the double bond on the carbon and oxygen flowing electrons onto the empty space, right? To form something like this. Now you have the plus sign switching from the oxygen atom onto the carbon. Why do you think that is? Because carbon normally want to form 4 bonds, because the valency of carbon is what? 4. But now it has 3 bonds. 1 bond to the oxygen and 2 other single bonds to carbon, right? So this is ketone tautomerization. The second step for the Enol formation is deprotonation. So the first step, protonation, you give hydrogen to a system. The second step is remove the hydrogen, deprotonate the system. So what will happen right here is that we have lone pairs on the oxygen. This is water, by the way, because if you abstract the proton from an acid, you know, the byproduct that you get will be water, right? So the water grabs a proton from this side, and the bond that is shared between the carbon and the hydrogen gets broken off onto the empty space on the carbon, right? Because there's a plus sign on the carbon. That means that there's an empty space for electrons to rent or to come sit in there. Okay, and there you have it. This is the Enol compound. Okay, why is it an Enol? You know, 2 functional group, an alkene plus an alcohol will be Enol. So E from the alkene, Ol from the alcohol, right? So now you have your Enol formed. As I told you earlier, the mechanism has 2 parts. The first part is the Enol formation, right? And the second part of it is the halogenation step. So the halogenation step, right, we have bromine is a halogen. So in this second part of the mechanism, the Enol that you formed in the first stage or in the first part of the mechanism is going to serve as the nucleophile, right? So you're going to have nucleophilic attack, where the double bond on the oxygen, right, flows back to form a ketone. And when that happens, you're going to have like 5 bonds on the carbon. Carbon will not be happy with 5 bonds. So what will happen is that the double bond will now breaks apart, grabs a bromine, which is a halogen. So that's what we call halogenation. You are just going to add halogen to a system, right? And then the bond that is shared between the 2 bromine atoms gets broken off onto the other bromine, right? So what is happening right here is that the enol that we formed in the first part of the mechanism becomes a nucleophile, right? And the nucleophile grabs a halogen, so halogenation. This is what you get. And remember, now we have a plus sign on the oxygen because oxygen has 3 bonds, but normally oxygen wants to form 2 bonds, right? So what do you think will happen? Of course, we have to do something so that the plus sign goes away. And before the plus sign goes away, electrons has to come sit in there. It's like a room, right? You have a room, you're giving your room for rent. You need people to come sit in there. So the plus sign right there means that, hey, we have an empty room, come rent it. So we got to push electrons into it, okay? So the 4th stage or the 4th step will be proton transfer. Proton transfer is also, in a way, you can say deprotonation, you know. You're just going to transfer proton from site A to site B. And so we call it proton transfer. And proton is hydrogen, right? So we see a hydrogen right there. So this guy abstract the proton or abstract the hydrogen, and the bond that is shared between the oxygen and the hydrogen gets broken off into the empty room, which is, you know, the orbital, or which is the plus sign. Okay, when that happens, this is what you get, right? You get a ketone functional group back and a halogen on the alpha carbon, right? So this will be a product, and then of course you remember this Br that got broken up from the other Br. It can also abstract a proton in the system and form HBr. Okay, that's not our concern. We already know that HBr will be the byproduct of this reaction. Okay, so just take a second and look at how the mechanism went by, okay? And then we'll go back to where the question is and trying to figure out what will be the product, okay? Okay, now let's flip back and go see what the question was about. Now that we've seen the mechanism was all about alpha halogenation of ketones. So you have a ketone, we are just going to halogenate the alpha carbons of the ketone. When you say the alpha carbons, right, this is where the ketone functional group is, right? This is the carbon with the ketone functional group. Just cover that one, and all the other carbons will have, you know, letters to it. So the first carbon attached to where the ketone is will be the alpha carbon, okay? So you have the alpha carbon. This will be your beta carbon, right? Because this is a second carbon all the way from where the carbon with the ketone functional group is, okay? On the same way, if you look on the other side, right? This side too will be an alpha carbon. That's right? Because this carbon is directly attached to the carbon with the ketone functional group. So this will be an alpha. This will also be an alpha. This will be a beta. This will also be a beta. And this guy can be a gamma carbon, right? So now that we know that the product that we will form will be an alpha halogenated ketone, okay? This is a ketone and this is your halogen. This halogen has to be at the alpha position of the ketone, right? So let's look at A. So we have alpha, beta, okay? So A, the bromine is at the alpha position. So is this correct or wrong? I would say it's correct. So if you chose A, that means you are right, okay? How about B? B has the halogen at the beta carbon. Would that make B correct or wrong? I would say not quite, okay? Because the product has to form at the alpha position, because the double bond, when we saw it, when we created the enol, which is the double bond, was formed between the alpha carbon and the carbonyl group. How about C? When we look at C, we see that bromine is attached at the alpha position on the other side. So that means that C is also correct. And that will make D an incorrect, because bromine is attached at the beta carbon. So this will be the product, right? We have our ketone functional group, we have the bromine at the alpha position. In this space, we will simply put either A or C. So you have your compound. You draw the ketone, and you have the bromine at the alpha carbon. Thank you so much for watching this video. Let me know what you think in the comment section, and don't forget to like and share. Thank you so much, and see you in the next video.
Me mix acid base boom reaction. Atom they dance like party attraction. KokoChem class be sweet like Cheeto. Learning they enter head pass and no coco